Okay, so today we are going to start the notes here for the hyperbolas. Today we're going to just define it, and we're going to also be able to find the vertices, the focus points, and also the asymptotes, and then graph that information, in addition to finding the center. So first thing we're going to do is define what a hyperbola is. And a hyperbola is the set of all points x, y in a plane. The difference of whose distance from two distinct points, which are called the foci, is going to be a positive constant. So again, this is what our graph is going to look like. It's actually going to look like two parabolas on the same graph. So it looks like it's got the happy parabola and the sad parabola, or it'll also look like the C or the backward C. You're going to be graphing them both on the same coordinate plane. So parts of the parabola are, it's going to have two disconnected parts. So these two disconnected parts are called the branches. And then the line that you could draw through the two foci that intersects the hyperbola at 2 points is going to call, those 2 points are going to be the vertices. And then the line segment connecting the vertices is called the transverse axis. And the midpoint of the transverse axis is going to be the center. Now, when we see the standard form of the equations, the first variable we see, the top of the first fraction, that's going to be the axis that it's transversing or touching. So again, we've got our branches here. Maybe I can go over it in a different color. So it looks like a happy parabola and a sad parabola. It's going to have vertices. It's going to have the center, which will be the midpoint between those two vertices. And then it's also going to have some focus points. And then it's either going to transverse the y-axis, it'll be vertical, or it's going to touch the x-axis, and it'll be horizontal. So the first examples we're going to do are going to be the ones with the center at the origin at 0, 0. The standard form of the hyperbola equation is going to depend on which axis it's touching. Now, when we did the ellipse, the x squared and the y squared stayed in the same spot. And then the a squared and the b squared are what moved. This time, the x squared and the y squared are what's going to move. A squared is always going to be the bottom of the first fraction. And then b squared will be the bottom of the second. Another key difference is it's got a subtraction sign in between the two fractions. And then the formula to find c squared, instead of being a squared minus b squared, this time it's got a plus sign. So notice how these two things have swapped places, the plus sign and the minus sign. Now, a squared again is always first. The variable that's in this top corner, in the top of the first fraction, this is going to tell you which axis it touches or which way it goes. So if you see the x squared first, you know it's horizontal and it's going to be touching the x-axis. If you see y squared first, it'll be vertical, and it's going to be touching the y-axis. To find your vertices, when the center is at 0, 0, and when it's horizontal, your vertices are going to be located at plus and minus a, comma 0, and your focus is going to be plus and minus c, comma 0. Because the a and the c are in the spot of the first letter that you see. Over here, your vertices would be at 0, comma, plus and minus a. These are the vertices. These are the focus. And then same thing here with the focus points. Your asymptotes, and we're going to see this on the next slide, whenever it's horizontal, the asymptotes are going to be the equation of the line plus and minus b over ax. And over here, y equals plus and minus a over bx. These are going to be asymptotes. So notice the asymptotes are these blue dotted lines. And when we go to graph our hyperbolas, we're going to graph those first. And we're going to use those as guides to make our hyperbolas. So we're going to think of them sort of like a wall or a boundary to make our graph skim along those asymptotes. So let's go ahead, and slide has the formulas for the asymptotes. So again, when it's horizontal or touching the x-axis, again, the formula would have been this: x squared over a squared and y squared over b squared, and it has to equal 1. So when you see x squared first, this is the formula you're memorizing for the asymptote. When it's vertical, it'll be y squared. Again, a squared is always first, and then the b squared. And when you see y squared first, then it'll be a over b. So just memorize these. Let's try some examples. Pretty good? All right, just like before, our equation has to be set equal to 1. So what I need to do here is divide everything by 16. And then I need to simplify the fractions. So the first fraction, 4 over 16, is going to simplify to 1/4. Then the next one, nothing to simplify. So let me just rewrite it. And then finally, 16 divided by 16 is 1. Now, notice nothing is being added or subtracted to the x squared, y squared. So I know there's no hk here. So because there's no h or k, my center is at the origin here. And that was the first thing it asked me to find. Remember, a squared is always first. So a squared equals 4. B squared is going to equal 16. To find c squared, I have to do c squared equals a squared plus b squared. I'm going to plug it in. Well, actually, let me go ahead and find a first. So a is equal to plus and minus 2. I'm square rooting them. Plus and minus 4. And then here I get 4 plus 16. C squared equals 20. So c is equal to plus and minus square root 20. I need to simplify that radical. I can make it 4 times 5, which simplifies to 2 square root 5. Yes?
So what did you say determines that the center is 0?
Because there's nothing being added or subtracted to the x squared and the y squared. So like, for example, here, if I had something instead of the top of this fraction, it would have been like x minus 2 squared. You would have had an h and a k there.
Okay.
And we're going to see that coming up. So if it's just a plain x squared, y squared in the top, you know your center is at the origin. 0, 0. All right, so for graphing purposes, now you probably will not be using a calculator for the quiz on Friday. So as far as graphing the focus points, if it's a radical, you can approximate it. So if you think about the square root of 20, think about it being in between these two perfect squares. Square root of 16 is 4, square root of 25 is 5. So you know you're just going to put your dot in between 4 and 5 for the focus point. Does that make sense? So again, you can approximate this. The square root of 20 is about 4.5, we'll say. So when we go to graph this, plus and minus 4.5. Again, your graph, you can just make it go by ones and just put it in between the two perfect squares. All right. Next thing we need to do, yes?
On the quiz this Friday, are we allowed to use our notes?
I don't know yet. I'll find out. It'll be on Lockdown Browser, so you would need to make like some type of study guide on paper.
Okay.
Okay, but I'll check with the other teachers. We're having a meeting today after school. All right, so next I need to find the vertices. That's the next thing they're asking me to find. The vertices use the A value. If you recall from, I believe, 2 slides ago, when the center is at 0, 0, and your graph touches the x-axis, you can find the vertices by just doing plus and minus A, comma 0. You're going to add the A to the center, and the variable that you added to is what you saw first. So really what we're doing here, and this will apply when the center is not at the origin, you would be adding and subtracting the A to the center, and the letter you added to is the first one you saw. So in this case, first letter I saw was x squared, so that's why I added A to it. And my center was at 0, 0. So my 2 vertices are at -2, 0, and +2, 0. These are my vertices. The next thing the question asked for was the focus points, or the foci. So for this one, I'm going to use the C value. So for the foci, remember when the center is at the origin and it touches or it transverses the x-axis, the foci are at C, plus or minus C, 0. Again, you would be adding and subtracting, so plus and minus C to the center of the first letter you see. And the first letter I saw was X, so that's why it's going to be 2 root 5 negative, 0, and positive 2 root 5, 0. These are your foci, or your focus points. Next, it wants me to find the asymptotes. So for the asymptotes, you're memorizing that the equation you're using when it touches, when you see x squared first, is plus and minus b over ax. This is the one when x squared is first. So we already have our a and b values, so I just plug it in. Y equals plus and minus 4 over 2x. B is 4 and a is 2. I can simplify this, and it's y equals plus and minus 2x. Yes?
What do you mean with the foci and the vertices when you say to add or subtract C from the first letter?
Okay, so my center point was 0, 0. So what I'm going to do is the first letter I see is x squared. So I'm going to be adding a to the x of the center. When it's at, yeah.
When it's not at the origin, we're just going to add and subtract C, right?
C to for the focus and add and subtract a for the vertices. And it's actually going to be a number other than a 0.
Okay.
Does that make sense?
Yeah.
Okay, now, when we're doing these asymptotes, they're going to be linear equations. So I want you to think y equals mx plus b. So I'm going to be graphing 2 lines. I'm going to be graphing y equals negative 2x and y equals positive 2x. Notice neither of them have a b, so my y-intercept on both of these when I go to graph is 0, 0. And then I'm going to use the slope. The negative 2 here is my slope. So I'm going to rise 2 and run 1. And it's negative. Oh, I said that backwards. This is rise. And this is run. Same thing here. Rise 2, run 1. And then I'm going to use these asymptotes as the guide for my hyperbola. So let me go ahead and draw a coordinate plane. Everybody good? All right, let's see. Let me come over here. All right, so here are the steps I'm going to follow for graphing. Number 1, graph the center. So in this one, my center is at 0, 0. Add some marks here. Number 2, graph the asymptotes. So I'm going to be graphing y equals negative 2x and y equals positive 2x. I'm going to do my asymptotes in red. So the first one I'm going to do is the y equals negative 2x. So I'm going to start at 0, 0. I'm going to go down 2 and over 1. I could also go up and left. When I connect the points, this is my first asymptote. It's the equation y equals negative 2x. Then I'm going to graph the equation y equals positive 2x. Up 2 over 1 or down 2 and over 1. Connect the points. Here's your second asymptote. It's the equation y equals 2x. Step number 3, graph the vertices. Let's see, my asymptotes were in red. My vertices I'm going to do in blue. They're the order pairs negative 2, 0, and positive 2, 0. Step number 4, I'm going to use the asymptotes as my guide. And I'm going to have my graph skim along them. So I'm going to graph the hyperbolas now using the asymptotes as a guide. I don't need precision. I'm just making them skim along these asymptotes that are like boundaries or walls. And lastly, I'm going to graph my foci. And again, we can approximate their location. And we saw that it was about 4.5. Let me add another mark here. 1, 2, 3, 4, 5. So I can put my 2 focus points like around here. Again, just an approximation. I can go over them in green maybe. And you're done. So we found the center. It was 0, 0. We found the vertices, the focus points, the asymptotes, and then we graphed everything. Now, when the smaller number is first, our graph is going to be kind of fat. It's going to be really wide. If the first number were bigger, then it might be a skinnier hyperbola. No co-vertices for this. Just vertices, focus, and instead we have asymptotes. Let's try another one. Again, we need to set it equal to 1. So the first thing I do is divide everything by 100. So I get y squared over 4 minus x squared over 25 equals 1. Notice the first variable I'm seeing. This tells me it's going to touch the y-axis. So I know my graph is going to look like the the U or the upside down U. Both of them together. So like the parabola, that's a U and an upside down U. Again, notice there's no h or k here. Nothing's being added or subtracted to x squared or y squared. So my center is at the origin. Remember, a squared is always first. So a squared equals 4. B squared equals 25. A equals plus and minus 2. B equals plus and minus 5. To find C, I'm going to do c squared equals a squared plus b squared. A squared is 4, b squared is 25, c squared equals 29, so c equals plus and minus the square root of 29. Again, to approximate the square root of 29, 29 is in between the two perfect squares of 25 and 36. So 29, it's closer to 25, so maybe around 5.3. Again, for graphing purposes, just put your point in between 5 and 6. All right, we need to find the vertices. Again, when the center is at 0, 0, we're adding our a value to get that vertice to the center, which is a 0. Again, the first variable we saw was y, so we're adding a to the y. So our vertices are really 0 plus and minus a. So 0 minus 2, 0 plus 2, or positive 2. These are the vertices. For the focus, we're using the c value for the foci. So 0 plus and minus c. So 0, comma, negative root 29 and 0, comma, positive root 29. For my asymptotes, you're going to memorize that when it touches the y-axis, you're memorizing the asymptote is plus and minus a over bx. So here my a value is 2 and my b value is 5. So my two asymptotes are y equals negative 2 over 5x and y equals positive 2 over 5x. So when I go to graph this, I'm going to rise 2 and run 5. Again, my center is at the origin, so I start at 0, 0. This is the first thing I'm going to graph. Pretty good? Ready for the graphs. So I'm going to come over here to the side. Graph the center first. Next, we're going to graph the asymptotes. So from my center, I'm going to rise 2 and run 5. I could also go down and to the left. So here is my first asymptote. This is this one. And then I'll do the negative. So I could go down 2 and to the right 5, or I could go up and left. Connect your points. And I'm not in Notability, so it doesn't make a very straight line. All right, so then this one is the y equals negative 2 over 5x. Next, I'm going to graph my vertices. They're at 0, 2 and 0, negative 2. Next, from that vertice, you're going to use the asymptotes as your guide and just swing it out here and let it skim along. Again, I'm just looking that you found the correct vertices and asymptotes. Again, I'm not going to make you look for additional points on the actual graph of the hyperbola besides the vertices. And then last, you'll graph the focus points. So I have a focus, and again, I'm approximating this. Just put it in between 5 and 6. So 1, 2, 3, 4, 5, 6. So you could put a focus point right here. And then another one right here. So these are the 2 focus points. And you're done. Again, you saw the smaller number was first. Again, nice wide hyperbola. Now we're going to have a shifted center. It won't be at 0, 0. But the process is still the same. Pretty good? Now we're going to introduce an H and a K. Okay, so same formula. Notice the a squared and the b squared. A squared's first, then b squared. Again, instead of just an x squared and a y squared in the top of the fraction, remember h is always with x, k is always with y. Notice x squared is first, so my graph transverses the x-axis, or it's touching the x-axis. Over here where the y squared is first, it's touching the y-axis, or it's vertical. For your asymptotes, remember we're going to be starting at the center, and our center is not going to be 0, 0. Now, you could also think of these asymptotes as being in point slope form. And if you remember, point slope form of the equation is y minus y1 plus, and then this was the slope. So in this case, when it's horizontal, the slope will be b over a, and then x minus x1. This is just going to be k, this is going to be h. Over here, same thing, but what changes is the slope. Again, this will be k, this is going to be h. All they've done on the highlighted yellow ones is they move the k over in front. So just be able to recognize different versions of this. So let's try it. All right, so let's try our first example. My equation's already set equal to 1. It's asking me to find the center, vertices, foci, and asymptotes. So the first thing I can do is find my center. So again, remember, the letter that's with y is the k, and this is h. So my center, opposite of what you think, is going to be at -3, -2. Notice the first letter I'm seeing is y, so it's going to touch the y-axis, or it's going to be vertical. So when I'm all done, I know my graph is going to look like the U and the upside down U, because I'm seeing y first. Again, a squared is always first, so a squared equals 9, b squared equals 4. A is equal to plus and minus 3. B is equal to plus and minus 2. To find C, I use c squared equals a squared plus b squared. Plug in 9 plus 4. C squared equals 13. But c equals plus and minus the square root of 13. Again, for graphing purposes, think about the 2 perfect squares on either side of 13. That'll be 9 and 16. So 3 and 4. So this will be probably around 3.5, 3.6. Again, put your point in between 3 and 4. All right, now let's find our vertices. Vertices are going to use A, and we're using the center point this time. We actually have to do some calculations here. So for the vertices, I'm going to be adding and subtracting A to the center, but the variable I add it to is what I saw first. So the first one I saw was y. So again, I'm going to take my center, which is -3, -2, and I'm going to add and subtract 3, which is my a value. So I have a vertice at -3, -5, and -3, +1. These are the vertices. For the focus, we're going to add the c to the center. Still to the y, because that's what we saw first. So this one we're going to add and subtract c to the center. So we're adding and subtracting root 13. So -3, -2 minus root 13, and -3, -2 plus square root of 13. So again, if I've approximated the square root of 13 to be like around 3.6, 3.5, when I go to graph this one, I'm going to put it at -3, -5.6, and -3, 1.6. Last thing I need to find are my asymptotes. When you're keying it in a WebAssign, you're going to key it in as simplest radical form. If for some reason they ask you to round it, then you would do it on your calculator, but radical form will be fine. For the asymptotes, we're going to be using, we can either do the one that was on the previous slide, or we can do it in the point slope form. So I'm going to subtract the k. So y minus -2. Remember, when it touches when it's vertical, we're going to be doing a over b. So plus or minus a over b, and then x minus the h. And let me put in the a and the b, sorry. So the a and the b are going to be 3 over 2. So y plus 2, plus or minus 3 over 2, x plus 3. If you put it like, so what's nice about this is, as far as graphing the asymptotes, you're just going to start at the center, and then you're going to move the slope. This is the slope, 3 over 2. And you're going to do it with a positive slope and a negative slope. So we'll start at the center, and then we just move the slope from the center. Now, if you put it into the form that was in the notes, all they did was move this 2 over, and you might see it written in this form. So just be aware of, you can manipulate this formula. If you wanted to put it into y equals mx plus b form, you could distribute and then combine the like terms. You could also do that. But it's a lot easier just to graph the center and then move from the center the slope. And I'm going to show you how to do that. And that's how we're going to graph the asymptotes. Let me come over here to the side. First thing I'm going to do is graph the center point. It's no longer at 0, 0. Remember, it's at 1, 2, 3, -3, -2. There's my center. Now I'm going to graph the asymptotes. Remember, the slope is going to be this 3 over 2. So I'm going to rise 3 and run 2 from the center. So I'm going to go up 1, 2, 3 and run 1, 2. I can also go down 3 and go over 2. So here is my first asymptote. And this is the equation with when it's positive. Then when it's negative, I could go down 3 and then over here to the right 2, or I could also go up 3 and to the left 2. There's your other asymptote. Next, I'm going to graph the vertices. I had a vertex or vertice at -3, -5. It's right here. And then I had another one at -3, +1. Again, use your asymptotes as your guide. And let them skim along the asymptotes. Throw in your focus points. So -3 and 5.6. Add in the number 5, 6. We could say a focus, it's like around there. Again, you're just approximating it. And then another one at 1.6, so like really close there. Those are your focus. Let's try one more, and we're done. Okay, so I could put a 1 under this, because there's an assumed 1. I can pull out my center. My center is at 3, 2. This is H, this is K. My A squared equals 1. My B squared equals 9. A equals plus and minus 1. B equals plus and minus 3. To find C, I'm using C squared equals A squared plus B squared. 1 plus 9. C squared equals 10, so C equals plus and minus the square root of 10. Again, I can approximate the square root of 10. It's in between the two perfect squares of 3 and 4. So it's really close to 9, so I could say it's maybe around 3.2. To find the vertices, again, see how we see X first? So it's going to be touching the x-axis. I'm going to be adding A and C to the X to get my focus and my vertices. So 3, 2, I'm going to add A, plus and minus 1. So my two vertices are located at 2, 2 and 4, 2. For the focus points, again, take the center, add and subtract C, again to the X. I should move that over. Add it and subtract it to the X. That was the variable I saw first. So for the focus, or the foci, it's going to be 3 minus root 10, 2, and 3 plus root 10, 2. So if I do 3 minus 3.2, I'm going to get about -0.2, 2. And then here, 3 plus 3.2, and that'll give me about 6.2. For the asymptotes, we're doing B over A because it's touching the x-axis. So again, put your center, plus and minus 3 over 1, x minus 3. You don't need to put it as 3 over 1, but if you want to have the rise and the run there, you can. So again, remember, we're going to graph the center, 3, 2, and then we're going to move the slope. Move from that, rise 3, run 1, and then we'll also do it with the negative. So let's go ahead and graph the asymptotes. So again, let's graph the center point first. It's at +3, +2. It's to get the asymptotes. From that center point, I'm going to rise 3 and run 1. So let's see. 1, 2, 3, and then over 1. I could also go down 3 and over 1. So here is this asymptote. I can also rise 3 and run 1 to the left, and then down 3 and 1 this way. Now I'm going to graph my vertices. I have a vertex at 2, 2, and then another one at 4, 2, and then use this as my guide, and then graph in the focus. And the focuses are around the point, the 2/10 and the +2, so around here, and then the other one is around 6.2, 1, 2, 3, and we can say it's right around here. And those are your focus. And that's it.